Hello everybody. In this video we're going to look at how to interpolate and extrapolate from a set of data by using linear regression. So what's going to happen in this assignment is you're going to be given a table of data, like the data that you see here. You're going to be asked to find the regression equation for a linear regression on this data, and then you will be asked to use that line of best fit that you found to find the y value, that is the range value, when x is equal to negative 4.94 in this case, and it will be different for each problem. But what we are doing is we are using our line of best fit to make a prediction about the y value when the x value is this. And hidden by my calculator over here, you also have a graph of this data. And when you type in your regression equation, that equation will be graphed on there so that you can verify that your equation matches your data. So in order to do this from the beginning, the first thing we have to do is find our line of best fit using a linear regression. And so we put that in the calculator as we know how to do. And at the end of this process, we can now see our regression equation. If it is required round to the thousandths place, you can see these numbers here do not continue out past the thousandths place, so that is not an issue. And I'll just type in my regression equation of y equals negative 5.9 x plus 5. And so now what we can do is we can use this regression equation to make a prediction about the y value when x is equal to negative 4.94. If I look over here at the graph, sliding my calculator over, I can see that that line of best fit actually looks like a line of best fit and is graphed well through there. I'm asked now to make a prediction about the y value when x is equal to negative 4.94. So that would be when x is about negative 5. And so as we look up here, we can see that this would continue up past where our graph stops at the top, but that we would expect this value at negative 5 to be somewhere around 40. It should be pretty high up there. And I can estimate that by looking at the line of best fit, but it turns out that I can do some calculations and make a far more accurate prediction. So here's what I do in order to do that. I'm going to take my equation, I'm just going to write it down here so we can take a look at it a little more closely. And what I'm going to do is I'm going to take this x value, negative 4.94, and I am going to substitute that in for x. Now this equation, all this equation does, and indeed all any equation of this type does, is it allows us, if we know a value of x, to do these calculations, negative 5.9 times whatever value x is plus 5, and that will give us our y value. So all I have to do is say y equals negative 5.9, and then I replace the x with negative 4.94, and I'm multiplying those two. They're written right next to each other. That's what that means. And then add 5. Now, of course, that's nothing we want to be doing in our head. So what I can do is I can come over here and enter that into the calculator. So I will clear out my regression, and now I'm just going to evaluate this. Negative 5.9 times negative 4.94 plus 5. And we can see that my predicted value is 34.146. Now remember, when I made a really rough estimation over here, I said, well, negative 5 should be somewhere in the neighborhood of 40. And indeed we get something that is in the neighborhood of 40. So when we enter this value in, again, round to the thousandths place, which is not necessary here as it terminates at the thousandths place. But we would simply type that in, and then as these are designed to do, we can then ask it to check our answer and see if we are correct. And here's hoping that we entered everything in properly. And indeed we have. So all we've done, we found the regression equation, substitute this value in for x, and that will give us our predicted y value.